Hello friends. In this video, we will take a look at the compact M100 presence sensor from the Tuya Smart ecosystem. There are several versions of it, with a 5.8 or 24 GHz radar, a Wi-Fi or Zigbee interface, and in either a wall-mounted or ceiling-mounted design. I have the wall-mounted Zigbee version operating at 5.8 GHz. Unlike conventional infrared motion sensors, this device uses microwave radar. It can detect not only active movement, but also a nearly motionless person, and it can also work through certain obstacles. In addition to presence status, the device determines the distance to the target and measures the illumination level. We will look at its internal design and check how accurately all of these functions work in practice. We will begin the logical part of the review with the native Tuya Smart system, then check how the device is transferred via Matter to Google Home and Apple Home, how the Tuya cloud integration works in Home Assistant, and then connect the sensor directly through ZHA and Zigbee2MQTT. We will look at the available entities and settings, the stability of presence hold, and the frequency of message transmission in the Zigbee network. Before we begin, please like this video so that more people interested in the smart home topic can find it, and subscribe to the channel if you have not done so yet. The sensor comes in a small cardboard box. On the front side, the Loginovo brand, the M100 model, and the main purpose of the device, human presence detection, are indicated. Both design options are also shown here, wall-mounted and recessed ceiling-mounted. On the side, the specific modification of the device is indicated. I have the version with a 5.8 GHz radar, a Zigbee interface, and wall mounting. Judging by the labeling, this same sensor is also available with a 24 GHz radar, Wi-Fi connectivity, and a ceiling-mounted design. The wall-mounted version is powered via USB with a voltage of 5 volts. The declared operating temperature range is from -20 to +70 degrees. Sensitivity is adjustable from 1 to 9, and the detection range is approximately from 30 centimeters to 9 meters. There is also a light sensor with a range of up to 2000 lux. Presence confirmation time can be adjusted from 0 to 10 seconds, and the turn-off delay from 2 to 1,500 seconds. The body size is 58 by 58 millimeters with a thickness of 11 millimeters. The package is minimal, but everything needed to get started is included. In addition to the sensor itself, the box contains a USB power cable, a small piece of double-sided tape for mounting on a wall, and an instruction manual. No power adapter is included. The manual in my package is in English. It describes connection to Tuya Smart or Smart Life, switching the sensor into pairing mode, installation methods, and the basic settings. Technical specifications and a diagram of the intended detection zone are also provided. The sensor is made in a compact square body with rounded corners. On the front panel, there is a human presence icon and 2 small indicator holes. On one of the sides, there is a USB Type-C power connector and a control button. It is used to switch the sensor into pairing mode and reset the settings. On the back, there is a sticker with the model and the main parameters, 5.8 GHz radar, Zigbee interface, and 5 volts, 1 amp power supply. The body is assembled with 4 screws, so the device can be disassembled without damage. After removing the bottom cover, the main board is revealed, occupying almost the entire area of the body. From the cover side, mainly the reverse side is visible, and through the central opening, part of the electronic components can be seen. The board is mounted inside the body separately and, if necessary, can be removed without damage. From the reverse side, all of the main electronics are already clearly visible. In the upper part, there is the Zigbee M100 radar module, below it the Zigbee module, the controller, power circuits, the USB Type-C connector, and the pairing button. Separate LEDs on the board correspond to the 2 holes on the front panel. A microcontroller from GigaDevice is used as the main controller. Next to it, there is a separate Zigbee module in a metal shield with a printed antenna placed near the edge of the board. This design is typical for Tuya devices. The wireless part and the main logic are implemented as separate units. The presence sensor itself is built on a separate Zigbee M100 radar module. It is directed toward the front panel of the body. This module operates at 5.8 GHz and is responsible for detecting movement, micromovements, and static presence. Now let us move on to the logical part of the review and begin with the native Tuya Smart ecosystem. To connect the Zigbee version, a gateway is required. I am using a Zigbee thread model from Moz with Matter support. I start searching for a new device on the gateway and power up the sensor. On first power up, it automatically enters pairing mode. The connection went through without any difficulties. In the system, the device was identified as a presence sensor, but with an image of the ceiling version. Apparently, from Tuya Smart's point of view, the wall-mounted and ceiling-mounted versions are almost no different. After being added, the sensor appears in the gateway device list and as a separate tile on the main screen of the application. The device plugin looks quite feature-rich, but in structure it is similar to other Tuya presence sensors. In the upper part, the current status is displayed, presence detected, or the room is vacant. Below are the illumination level, sensitivity, and the calculated distance to the target. The light sensor works. In the left screenshot it shows 110 lux, and when placed directly under a lamp it reaches the maximum 2000 lux. The default sensitivity is set to the 9th maximum level. When no presence is detected, the distance to the target is 0. Detection delay, which is disabled by default, and the transition time to the no one present state, 5 seconds, are also configured here. The out-of-the-box detection range is set from 0 to 6.6 meters. One of the features of microwave sensors is the ability to work through obstacles. To test this, I placed the device between two cubes that completely blocked its direct line of sight. The illumination level, as expected, dropped almost to 0. The application showed 9 lux. Then I left the room and waited for it to switch to the no presence state. As soon as I reappeared in a straight line in front of the sensor, it triggered even through the obstacle. Presence itself was held quite steadily, but distance measurement turned out to be not very accurate. At a real distance of 3.5 meters, the application showed almost 5, and when I was very close, approximately 15 to 20 centimeters away, it displayed 61 centimeters. The log allows you to view the history of sensor triggers and transitions between the presence detected and no one present states. According to my observations, while I was nearby, roughly within 1 to 1.5 meters, the sensor did not lose presence and held it steadily. A history of illumination measurements is also available here, with data displayed by day, month, or year. The settings include ready-made profiles for different rooms: living room, bedroom, toilet, and sleep mode. In addition, all parameters can be changed manually. Sensitivity is adjustable from level 0 to level 9, and the transition time to the no one present state from 0 to 1,500 seconds. The near and far boundaries of the detection zone are configured separately. The maximum value is 9.5 meters, so it is possible to exclude areas that are too close or, on the contrary, too far away from the monitoring zone. A delay before presence confirmation is also available, from 0 to 10 seconds. All of these parameters can also be changed according to a schedule. For the selected time and days of the week, sensitivity, near and far boundaries, detection delay, and the transition time to the no one present state are specified. This makes it possible to use different sensor settings, for example during the day, at night, or on weekends. The main use of the sensor in automations is as a trigger. You can use the presence status itself, as well as the distance to the target, greater than, less than, equal to a specified value, or within a certain range. In addition, the transition time to the no one present state and the illumination level are available. In the Actions section, almost all of the sensor's main parameters can be automated. For example, sensitivity, near and far detection boundaries. The delay before presence is registered, and the transition time to the no one present state can be changed. This makes it possible to adapt the device's operation to different scenarios and times of day. In the general settings, everything is standard for Tuya devices: sensor information, loss of connection notifications, sharing, group participation, update checking, and removal from the system. At the time of testing, the out-of-the-box firmware version was up to date. As I already mentioned, the gateway being used supports Matter and is connected through it to other smart home control systems. Let us start with Google Home. The sensor was successfully transferred through the bridge and appeared in the general device list as a presence sensor. Presence statuses are updated correctly and almost in real time. The application shows whether the room is occupied or not. The illumination level is also transmitted via Matter. The values match the data in Tuya Smart, although in Google Home they are displayed for some reason with an accuracy down to 10,000ths of a lux. The same gateway is also connected to Apple Home via Matter. In the list of home hubs and bridges, it is displayed as a separate bridge through which one accessory, our presence sensor, was transferred to the system. In Apple Home, the device was identified as a presence sensor with two sensors. In addition to the room occupancy status itself, the illumination level is also available here, and its value is displayed directly under the device name. If you open the sensor card, you can separately see the presence status and the illumination readings. For testing, I first placed the device in a dark location and then under bright light. The value changed from 46 to 1700 lux. That means both functions of the sensor are transmitted correctly via Matter to Apple Home. Before disconnecting the sensor from the gateway and moving on to alternative control systems, let us check the native Tuya cloud integration in Home Assistant. This is not Matter. We already looked at that earlier. Here, the sensor also appeared and is displayed as a separate device with 5 entities. On the device page, the presence status, the distance to the nearest target, as well as sensitivity settings and the near and far detection boundaries are available. At the same time, the illumination sensor is not transmitted through the native Tuya integration. Now let us move on to alternative control systems and start with Home Assistant's native Zigbee integration, ZHA. As the coordinator, I use the Home Assistant Connect ZBT1, previously known as SkyConnect. I start adding a new device through the coordinator. Before that, I remove the sensor from the Tuya gateway, after which it automatically enters pairing mode and becomes available for connection to another system. ZHA detects the device correctly and completes initialization without errors. Even at this stage, it is clear that the system has recognized several objects and settings right away. Now let us see exactly what data is available here. All the main entities and settings appeared on the device page. The sensor itself is identified as a Zigbee router, which is normal for a permanently powered device. Presence status, illumination level, distance to the target, detection and turn-off delays, near and far boundaries, and sensitivity are all available here. The light sensor works correctly. Under normal room lighting, it shows intermediate values, and when placed directly under a lamp, it reaches its maximum, 2000 lux. I also checked separately how stably presence is maintained. I was about 1 to 1.5 meters from the sensor and working at a computer, so movement was minimal, mostly just my fingers on the keyboard. During 32 minutes, the sensor never once switched to the no one present state. So in this scenario, it works quite confidently. Now let us move on to Zigbee2MQTT. After removal from ZHA, the sensor automatically entered pairing mode and was immediately discovered by the new system. The connection went through normally, the device was identified correctly, and this time already with the correct image of the wall-mounted version. In the advanced information, it can be seen that the sensor works as a Zigbee router. Its model, manufacturer identifier, network address, a link to the device page in the Zigbee2MQTT database, and current activity are displayed here. From here, you can also change the device name and add your own description. On the Exposes page, all the main sensor data is available: illumination level, presence status, and distance to the detected target. Values are updated in real time, and distance is displayed in meters. Radar sensitivity adjustment is also located here, from level 0 to level 9. Below are the working zone and time delay settings. The near and far detection boundaries can be changed within a range of up to 9.5 meters, the trigger delay from 0 to 10 seconds, and the transition time to the no one present state from half a second to 1,500 seconds. At the very bottom, the Zigbee link quality is displayed. One of the important points for sensors like this is the frequency of sending messages to the Zigbee network. This sample transmits data approximately once every 1 to 2 seconds. That is quite active, although there are models that send 5 or 6 messages every second. In a network that is not too heavily loaded, such a sensor most likely will not create serious problems. But if there are many devices with similar behavior, a separate Zigbee network can be organized for them. For example, on a separate network coordinator. Overall, the Loginovo M100 turned out to be a quite functional compact presence sensor. The device is produced in several versions, but in this review, it was the wall-mounted Zigbee version with a 5.8 GHz radar. The package is minimal, power is supplied continuously through USB Type-C, and double-sided tape is provided for installation. In terms of sensitivity, the sensor performed well. During testing, it held presence steadily even with minimal activity at the computer. Like other microwave radars, it is capable of working through obstacles, which can be either an advantage or a source of false triggers. Therefore, the installation location, range, and sensitivity are best selected experimentally. Among the noted peculiarities, the distance to the target is determined with a noticeable error, so it should not be used as a precise measuring instrument. The illumination sensor, however, works quite predictably within the declared range of up to 2000 lux. Compatibility is good. In Tuya Smart, extended settings are available, including sensitivity, detection zone boundaries, and time delays. Through Matter, presence and illumination are transmitted correctly to Google Home and Apple Home. In the Tuya Cloud integration for Home Assistant, the set of functions is smaller, without the illumination sensor, but with presence status, distance, and part of the settings. Through ZHA, the device also works almost completely. In Zigbee2MQTT, the sensor is supported out of the box, with all the main entities and adjustments. One nuance is the fairly high data transmission frequency, about one message every 1 to 2 seconds. For a small network, this is unlikely to become a problem, but a large number of such devices may create an extra load. In the end, this is not an ideal sensor, but quite a functional presence sensor with good compatibility and broad settings. That is all. I hope the video was useful and interesting for you. I would appreciate your likes. They help promote the video on YouTube. If you do not want to miss new reviews and smart home tutorials, subscribe to the channel. All the links mentioned, as well as my Telegram channels, social networks, and discussion groups, can be found in the description below the video. Thank you for your attention. See you again. Peace to everyone.